all of your names here today. I said names because, as you know, we are unable to see your smiling faces. But please know that as panelists, Dean Toole, Gary Leidich, and I can see your names. So rest assured, we know you're here and we really appreciate your support and look forward to your participation. So it looks like quite a few of you are continuing to join us, and I am not at all surprised. Today's guest of honor, Gary Leidich, will be sharing with us information that is pertinent and intriguing to all of us, including folks like me who are not engineers. Many of you may already know me. If not, please feel free to reach out to me after the event. My name is Jennifer Hall, and I serve as the Director of Development for the University of Toledo Foundation, where I have the honor of working very closely with the College of Engineering. As I already mentioned, we are unable to see your video and hear your audio. However, you can freely chat with us by using the chat box, which you should already be able to see on your screen. If you don't see it already, please go to the bottom right-hand corner of your screen where you should be able to see a little chat icon. Once you click it, the chat panel will appear. This is how you're going to be able to submit questions directly to Gary and Dean Toole and to me throughout today's town hall. And finally, if you want to change the view on your screen, you might want to expand it or see multiple people at once or just see the person who's talking. Just head up to the right upper corner and you'll see an option to expand or reduce your screen. If you have any issues at all, just send a chat message to me at any point and I'll help you out. Okay, let's switch gears and get things started by turning things over to the Dean of the College of Engineering, Mike Toole.
Thanks, Jennifer, and I appreciate, as usual, all the great work you've done in setting this up. I love these town halls. It's great. We're showcasing all the wonderful things in our university, and that includes our alumnus, our teachers, all those things. So it's a great day, and I appreciate everybody joining us. Real quickly, if I could just mention two things that I'm excited about. Things are looking up, right, as our nation opens up again. UToledo has named, if you haven't heard, Dr. Gregory Postal as our permanent president. And I can tell you all the deans, just so many of us are really happy about that appointment. We've been very, very impressed with his time here at UToledo. Amazing how he has just quickly got a hold of the key issues, the challenges we're facing, the key opportunities, and run with it. So we're delighted with that. And I think you're going to hear great things about UToledo in the next couple of years. I'm confident of that. The second thing I want to let you know is we, of course, are very committed to student success, having a safe and healthy community. We also know that teaching is best face-to-face, right? We're a residential campus, always has been, and I think always will be. And so in the fall, we're trying very hard to go back to a completely normal, we'll say. We still have the CDC issuing 6-foot social distancing. And so that's tough, right? You can't have normal when you do that. But we're confident that it's going to be down to 3 feet in the fall. So we're trying to schedule classes that are only 3 feet social distancing, and we're allowing up to 100 students in a classroom. And we're hoping that the CDC will even change it further and we'll be able to go back totally normal toward a face-to-face. So that's the plan for the fall. Still be wearing masks. We think, quite sure about that, but at least we'll be back to a normal campus, and hopefully there'll be football games and all of the good sports and things that make Rocket campus just an exciting place to be. So I wanted to share that with you a little bit, but I want to jump right into our guest today. And Gary Leidich is not only a dear friend, but you'll hear about multiple roles in the college and particularly at the university, but particularly in the college. So Gary, I'm so thankful for you joining us here today and giving us your time. Now, folks, I got to tell you, Gary and I were talking, and we're going to have a conversation today, but as we looked at some of the questions that were coming in from the registrants and some of the questions that I had and others had, there were some cases where Gary said, I got a great slide from the courses I teach that'll help communicate that. So we've kind of done a little bit of preparation. In some cases, you'll see Gary call for a slide to show. And so we appreciate that. All that he's accumulated over the years, hundreds and hundreds, you're only going to see about 10 today. But anyway, Gary, thanks again for being here today. Hey, let's start on the personal side, right? The life story. I know you got a Bachelor of Science in Electrical Engineering and a Master of Science in Engineering from UToledo. Where did you grow up?
Well, first of all, Mike, thanks very much for having me. And to your point, we won't make this death by PowerPoint. I think we all know what that looks like.
Right.
But yeah, I was born and raised in Ashtabula, Ohio, which is in the northeast corner of the state, and graduated a long time ago from high school. And I was very fortunate to earn a scholarship at the University of Toledo. Always had my eye on engineering, math, and science, and even in the utility business, even when I was in high school. I remember my dad saying, you know, you'll never be rich, you'll never be poor, but you'll always have a job. And we need electricity. So that kind of stuck with me for all these years. But again, I got a scholarship. I went to school during the Vietnam era, so it was a real tumultuous time. Somehow I got through it all and graduated from the university and was delighted to be able to come back and help out.
And you've done that very well. So tell us about your positions in the power industry, and don't be humble, because you are truly known across the nation as a number of executive positions. So I think it'll help everybody to understand what this rocket engineer has done. So if you would, and also, when did you first know, like, hey, I think I could do pretty well in electricity here and power in general? So trace your career, if you would, Gary, and don't be humble.
Well, okay, we don't. I appreciate that, Mike. And you know, I started out, and like I said, with an interest in the utility sector, and I never really thought about whether I could be successful or not. I've always approached it as do the best you can, and what happens happens. And fortunately, I've been in many positions where I've kind of been at the right place at the right time, and have been very fortunate in my career. I got interested in nuclear power in college. We were building a lot of facilities back in the 60s and 70s, and I joined the Cleveland Electric Illuminating Company and worked at the Perry Nuclear Plant in design and startup of the plant for about my first 10 years of my career. Moved to the corporate office, had a number of different positions, system planning, which was kind of using my power systems background. I had a power systems curriculum here at the university. It was a real strong program back in the day, and moved through a number of different positions with the utility. I did spend 5 years at the Institute of Nuclear Power Operations because I've been kind of on the nuclear side of the business much of my career. Came back at the request of the company to help out with the situation at Davis-Besse, and then I retired at the end of 2011, and I've been doing whatever I want to do ever since then, including this.
Well, you've been helping out a lot of people. You're on a couple boards. I remember that. I also remember, didn't we? You also have a connection with my alma mater. You did some work at MIT, is all. So tell us about the boards. Tell me about the MIT work.
Yeah, I currently serve on the board of the Western Electricity Coordinating Council, which has the oversight of the reliability for the Western interconnection, which is the western half of the United States. And I serve on that board as an independent member because I'm not associated with the companies out there. So
Sure.
that's kind of how that works. A number of very interesting issues, particularly the state of California, which is a whole other subject. But we deal with a lot of real challenges in terms of the generation and transmission and the footprint out in the West, which is very different than the Eastern interconnection, where things are very closely coupled. Also serve on the board of the University of Toledo Foundation, and that's been a real great experience for me. And the work at MIT was teaching a couple of courses in nuclear, and we had a course in particular where we taught nuclear power to non-engineering executives,
Ah,
and it was fun. It was a challenge, but they really walked out of there with their brain pretty scrambled. So it was a good experience. Good experience.
oh, great. Hey, before we get into the kind of meat of electricity and power today, I know your family is very important. As I've gotten to know you and Marla, family is a big part of your life. Tell us about your family a little bit, and if you got a photo or two, show them.
Oh, well, there goes the rest of the hour, I tell you. Now, I'll be brief here. Between Marla and I, we have 6 children, and the most relevant picture I could find, and we have 10 grandchildren, by the way. So we got what's called a big payroll, and the most relevant picture I could find is this is one of my granddaughters, Noelle. She lives in Columbus, right in the middle of the Ohio State Territory, and she's got the right shirt on. And hopefully she will be someday an alum from Toledo. Her dad, my second oldest son, is an alum from Toledo from the School of Business, and he's done very well. So we'll continue that family tradition.
Very good. Very good. Well, thank you for sharing that. So let's jump into the kind of some technical issues and the market issues. So let's talk about changes in electricity generation in the U.S. and in Ohio, in particular, over the last, let's say, 30 years. Has total demand grown steadily? And what's the expected growth in demand over the future? And then, if you don't mind, talk also about the sources of that electricity, right? How have the fuel sources changed in the past, recently, and going forward?
Yeah, thanks. And this slide that we have here is really the best picture of the history and several important points. When I started in the business back in the early 70s, you could see the load growth from 1950 to 1970, and that really started back at the end of World War II. Electricity was growing 6 to 7% a year, and with the oil embargo and the energy crisis, that slowed down. So that's what that change is, and that's a significant change. When I started in the business, we could not build power plants fast enough to keep up with the load. And of course, now we don't have that problem at all. We're
Right.
kind of living off the plants that we built back then. The growth has been pretty steady over the years. You can see the 2008 recession. That growth rate is about 1.5% per year. And this is a government chart from the Department of Energy. And their projection is that we'll see a pretty steady growth going forward of about the same. So you can see it's kind of flattened out. I mean, this is like any other projection. It's probably as good as the weather forecast, right? So, we really don't know what's going to happen, but things like electric vehicles could change this. Actually, could make it go up even more, depending on where those are and how that's moving forward. So that's a factor. Energy conservation has something to do with this. That's what we've seen over the past few years. That's kind of why it's flattened out a little bit. But I will tell you this, in fact, I can give you an example. When my grandkids walk through the front door, the older ones especially are looking for a place to plug in their phone, right? So, it's just it's a must-have product, and people do not hesitate to buy more gadgets and plug them in the wall. So I think the growth will continue even at a modest rate. The next
Yeah.
chart shows the power plants, and relative to your question about what's the mix here, and this goes back about 10 years. And you can see that coal-fired generation is coming down. We all know that. It's reduced, pretty substantially over the past. In fact, in Ohio here, about 10 to 15 years ago, we were about 80 to 85% coal-fired generation, and now we're about 30. So, that's good for the environment, not so good for jobs, but a lot of those plants have been replaced by natural gas plants. And you can see the growth in natural gas over the last several years. It's kind of displaced coal. It's obviously better for the environment. It's still a fossil fuel, about 40% of the CO2 emissions that you get out of a coal plant. But being near the Marcellus Shale and all the gas in the southeast part of the state, it's a great resource. And we have a number of new plants that have been built recently that are natural gas. You can see nuclear is kind of steady, and then the picture for renewables is really one of growth here.
Yeah, I can see that. Before I ask about the renewable, because I have a question about that, thinking back to the demand, right? And the chart that before that was the growth. And of course, the units were kilowatt hours. But Gary, help us to understand how when we talk about demand, it's not just yearly, it's not monthly, it's hourly, it's minute by minute. That is so important for the management of it. Just share a little insights on that before we talk about renewables.
Yeah, most people don't kind of realize this. Everybody just walks in the room, turns the switch on, and the lights come on, and life is good, right? So nobody kind of knows what's going on behind the meter, if you will. And the reality is that the generation that we see here has to match the load exactly every minute, every second of every day. And if it doesn't, the system starts coming apart automatically. So given that, this generation has to follow the load, and the load varies substantially. Just think about your own home. Your electricity load probably peaks between 4 and 7 p.m. and then middle of the night it's nil unless you've got electric heat or whatever. So that load cycle like runs 60% variations, and it's the same seasonally. Here in Ohio, we are a summertime peaker, which means that our load is substantial in the summer compared to the spring and the fall. a little bit higher in the winter. So those variations are huge, huge load swings, and that generation follows it every second of every day.
Right. And it's 24/7, right? You're always on the clock when you're in the power industry. I see that. Thank you for that. Help me understand it. Hey, looking again at the chart that we see there, and we look in the upper right at the renewables, as you mentioned, and the growth in that. So that's a good thing, I think. Does that mean that we're going to be able to meet our climate change goals? Are we going to mitigate that and be okay that because of that growth in that upper right corner?
Well, that's a great question. This chart, just as a matter of background, is from the Energy Information Administration, which is part of the Department of Energy. And
Okay.
this is a technical source. So this is their projection of kind of what's going to happen based on a number of other inputs and forecasts. And you can see that we are essentially doubling the renewable footprint by 2050, and that's a good thing. Because obviously it's a carbon-free source. The challenge with this chart is that if you listen to the aspirations that are out there, both globally and here in the United States, this doesn't meet that. In other words, we still have coal and natural gas, which are carbon emitters. And in fact, the Biden administration's goal is to actually have that carbon footprint go to zero by 2035 for the electric sector. So that's a daunting challenge. So there is a disconnect here, but I think, in fact, the president has called for the climate summit, which is going on right now, and the international leaders are putting their goals on the table. And President Biden's goal, which he just announced this morning, is a good one, which is to reduce by half our emissions from the year 2005. So that's different than zero by whenever, but it's very good progress. In fact, we've made great progress in the electric sector. And this isn't a chart of emissions, this is generation fuel, but you can see by coal. The electric sector has done a great job of reducing emissions and will continue to do that. So a lot of work to do here.
Yeah. So we're going to be decarbonizing or not? I remember you had a good slide on that.
Yeah, I don't know. This is one of my favorite slides, and it's it goes all the way back to when we started, right? In 1776, and it talks about energy consumption. So this isn't just electricity. This is all energy. So this includes, your natural gas furnace, your automobile, everything that we do here in terms of energy consumption in the United States. And it's in quadrillions of BTUs. That's a real big number. And what you can see here is the energy consumption sources over time. And you can see wood and you can see coal coming up. You can see petroleum, that's oil, that's our cars by and large. The transportation sector is the largest carbon emitter in the US at this point in time. And then you can see things tailing off. The coal is being reduced in recent years, natural gas coming up, petroleum. So the point here is if we're going to decarbonize completely, the petroleum, natural gas, and coal all have to go to zero. And that's the ho hum. I mean, that's like, wow, over hundreds of years we've developed this pattern of energy consumption that we're going to have to reverse. So there is a lot of work to do, and it's a daunting challenge. But I'm pleased to see that the world leaders are working together to get this thing turned around. Lots to do.
Yeah, that's good. And again, you helped us. It's really important to understand, to keep in mind, there's electricity generation and then there's energy, and they're really different. But when we talk about climate change and lots of other things, we got to keep those separate. So and it's neat that you're an expert in both those things. Well, good. Hey, so I got some questions. Let's talk about. And by the way, you pointed out, I appreciate that. I'm always, anytime I see an infographic, if it's compelling, I'm gonna like, where is that from? And you already stated everything you're showing today is from government sources, right? So that's good. You didn't get it off some whatever website, and you didn't make it up. So let's talk about the importance of affordable and reliable electricity, right? That's, as you said, that's important for both our economy and our quality of life. And so is affordability really that important? And if so, how is the U.S. doing on affordability and Ohio in particular?
Yeah, okay. Yes, obviously affordability is important. I tell you though, I think a lot of people frankly don't pay a lot of attention to it. I mean, sometimes the billing is even on autopilot, and
Mm,
it's a portion of the budget. I'm sure they wish it was lower, but from a value proposition standpoint, I think you really get a pretty big bang for the buck on electricity. In terms of our position relative to the rest of the world, we're pretty economical. If you use residential rates, which is a good measure of things, that's kind of what we pay at home. The national number is 12.8 cents a kilowatt hour as of the end of last year. Germany's like 36 cents. The rest of Europe is 20 to 25 cents. Japan is 26 cents. So we do pretty well in terms of affordability and the overall price. The other thing that's interesting, if you look at the growth over the years of electricity, and you go way back to the turn of the last century, electricity has grown about 1.5% a year in terms of sort of inflation, if you will. And food at the grocery store has been 3 to 4, housing's been 4 to 5, and so overall we've maintained pretty good affordability. Ohio's rates are less than the national average. A lot of our generation is cheaper than other generation, and I think that'll stay that way even with natural gas. We're running about 11.8 cents versus the national average of 12.8. California is 20 plus. Hawaii is 30, but still might be worth it. I don't know. So anyway, I think we're doing pretty well on affordability.
Very good. Yeah. And I remember the range across the nation. It really is something there, and so that's good. And of course, we also know it's not just how much we're paying for to heat or put on light or power our houses, but also our industry, our economy, right? Our manufacturing. We want to bring advanced manufacturing, restore the Midwest and particularly Northwest Ohio to its greatness, and that the electricity prices are part of it. Hey, let's talk now about the same sort of thing for reliable electricity, right? How important is it, and how are we doing to achieve our goal for a reliable source of electricity?
Well, how important is it? I mean, everybody just goes ballistic when the lights go out. I mean, there is absolutely no doubt about the stress caused by a lack of electricity, and probably more so than any other commodity. I mean, it's just something we absolutely have to have, and people suffer badly, as we saw in Texas, without it. So the reliability is good here. The numbers are like 99.99, and the experts talk about how do we add another 9 to that kind of number. We have a lot of storms here in the U.S., and so we have a lot from that. Otherwise, our numbers would be better. Relative to the rest of the world, it's a high variability, Mike. In Europe, reliability is actually better than ours. The network's a little more closely coupled. They have a lot more underground services. They're less spread out than we are. We have a lot of rural areas. In other parts of the world, India, Africa, a third of the country has no electricity. So there's just a wide variation globally in terms of development. There's a lot of growth that is going to occur globally here in electricity. We're pretty mature and developed, and we see countries growing like crazy in terms of electricity, power plants, including coal. So a lot of work to do there.
So speaking of reliability, I think about smart grid, right? And how that can help reliability and I think affordability as well. So we could spend an hour or two or days on the smart grid, and I know you know enough that just summarize a smart grid for us. What does it mean for us, and how does it work?
Well, we could do. In fact, I do a couple lectures on smart grid, but basically the idea is improve communications between the customer and among the customers and between the customer and the utility. And the best example is a smart meter. A smart meter allows for two-way communications between you and the utility. The old meter is just one way. In fact, a meter reader would come around and read the thing, okay? And the smart meter can send electronic signals. It can tell the company, the utility, when the power is out at a given home. Right now, that's a phone call, unless it's a big area-wide outage. So a lot of improvements possible there, and all those affect reliability, and I think overall will improve the economics as well.
Very good. Speaking of reliability, what the heck happened in Texas this winter? I'm sure it's technical, but you'll also help us to understand what went on.
Yeah, well, let me start with something that probably most people don't realize. There are 3 interconnections in the United States. I talked about the Western interconnection and my role out there, and then there's the Eastern interconnection, which is where we sit. And then Texas has their own interconnection, and this goes all the way back to the 1930s, and the Federal Power Act was first developed. Texas said, we don't want any part of interstate transmission lines, and we don't want to be regulated in that regard. So they aren't. So they have their own grid. Now, it's a grand debate on how much that contributed to the situation. It was part of it. It's certainly not necessarily the solution, but it's an interesting kind of factoid that led up to the event. And the next slide is kind of a busy one. Talks about the event. I'm not going to read it to you. I think everybody pretty much knows what happened. The major winter storm came, and the short version is it got very cold in Texas, and the system, the hardware, the power plants just is not designed for that kind of an extended cold spell. That's the short version. So generating units started tripping off. Some of those as a result of frozen water lines, much of it due to natural gas shortages because natural gas was needed elsewhere. And the gas companies had their own problems with frozen equipment. At one point, almost half of the generation in the state of Texas was out of service. And you get to a point, again, there's no interconnections. You get to a point where that's it. And as I said earlier, you have to match the load and the generation every second, every minute. So the system operator, which is ERCOT, they ordered a rapid and systematic load shedding, about 16,000 megawatts of customer load shed at the highest point, 4.5 million customers out of service. And as you can see, about $160 billion in losses and over 100 fatalities, unfortunately. They ordered the shutdown. Frankly, it could have been worse. I know that sounds rather daunting, but the system starts automatically disconnecting itself if the load and generation don't match. It's under frequency load shedding for your techies. And that did not happen. The operators took control and had these outages in a controlled fashion to keep the rest of the grid intact. So one version of this is the ERCOT operators were actually pretty heroic, even though they were under a lot of criticism that they could have had a significant event, even a more significant event, lights out in Texas completely. There's also a lot of market issues. The PUC in Texas established a price cap of $9,000 a megawatt hour. Just to give you a frame of reference, the normal prices are like 20 bucks. Okay, so, and in cases where customers had the ability to buy wholesale power directly, that's how you heard about the headlines of the big power bills. They have retail choice in Texas, and many customers signed up to basically buy wholesale plus. So if that rate moves like it did, the customers wound up paying for it. Some utilities wound up paying for it. Several bankruptcies have been filed. A lot of fallout, lost jobs, resignations of board members, a whole bunch of consequences. And the bottom line at this point is we're still sorting through it, and it's going to be interesting to see how Texas responds to all this. One thing we do know for sure is there will be improved national standards for winterization that will apply to everybody in the country, because that really is kind of the primary cause of the thing here. They just weren't fully prepared for this.
Very good. That's a great explanation, and it helps us to think about, I guess, a combination. First of all, this issue of living the spot market, right? Which is most of us are not doing. We just had that set fee, and yet sometimes when we go invest into equities or something, right? Stock market, that's the spot market, right? So we always got to decide, but most of the time, unless you're dealing with derivatives, options or something, it's not as volatile as electricity was in Texas during that period, I think. But you did a great job of helping us to understand, you mentioned climate issues, and that is, that it was darn cold down there. You mentioned political decisions that had been made in the past, system decisions. So I want to go back, if we can, to our renewable energy. Yeah, go ahead.
There we go. I did want to show
one. Yes. Oh, yeah,
sorry.
Good. Right.
I forgot to throw this in here, but
yeah.
This is a classic, and it's very simple. This is the Weather Service, and we all recall those days when it was so cold. And of course, we didn't have any outages. We had a few, but it was distribution where snow and ice and poles fell down and wires fell down here and there. But our plants here in Ohio, and this intuitively, are designed to be able to handle all of this kind of cold weather. So that can that happen here? In the utility business, you never say never and you never say always, right? So anything's possible, but it's pretty unlikely to have the wide scale kind of outages that Texas had up here in our part of the country. Okay.
Right.
Thanks.
No, that's good. And you know what? Now that my colleague Samir Hevzi in mechanical engineering just posted a good question. He said, does that mean that it was not reliable in Texas? And I think, let me take a shot at the answer is they did make decisions, as we all do when we're designing engineering systems, right? We made decisions for the parameters of the environment or other things that we wanted to have be reliable. And then we were things outside that we're willing to take that chance. So what's your thought on do you consider the Texas system to be reliable?
Well, that's a loaded question,
I
but
guess it is. Yeah.
obviously, you're right, Mike. It's a matter of establishing criteria for reliability. And the thing I will tell you is that Texas has kind of gone it alone here. And I think that contributed to the situation. The Public Utilities Commission in Texas basically outlines the market rules and establishes the rules of the road. They have been running thin on reserve margins in Texas. Most of the problem they've had over the past several years has been during the summer. And when your load's high due to air conditioning loads. So from that standpoint, this was, you never say it's a 1 in 100 year storm, but it is. Okay.
Right.
And the challenge here, Mike, and we've talked about this before, is with the climate changes that we are seeing weather changes. And this kind of thing, may very well happen again. And I think that's why there's a push for improving the standards. There's guidelines for winterization of power plants. Those will become standards and enforceable. So that's a big change that's coming.
Your answer, very good answer, just made me realize, Gary, that sometimes it's a trade-off between affordability and reliability, right? Because to expand that range, you got to pay for that.
Yeah, and especially in their case, the plants and the gas system really weren't designed for this kind of weather from the beginning. So retrofitting that, it's going to be very expensive. When we build a power plant here in the North Coast, if you will, we put the turbines in buildings, we winterize everything because we're ready for 7 degrees Fahrenheit. On the other hand, if it was 20 below here for a week, we'd really have our hands full. So it's a function of what's your design criteria.
Yep, very good. I want to go back, if I may, to renewable energy, and so because you just talked about it with Texas again, there was climate issues, physical issues, there were decisions made. How about with the sources of renewable energy? Remember, we saw that growth of various sources. So help us to understand, within the U.S. versus other nations, or maybe state to state in the U.S., what are the factors that influence the growth of it? Is it climate? Is it government policies? Is it, partisan politics? I'm not trying to get us divisive here, but just trying to get a sense for why we are in each state for our sources of various sources of renewable energy.
Yeah, well, really, Mike, it's all the above, including politics. And there's a lot of momentum now with the new administration to really get after this. And I think that is gonna help us move in the direction of carbon reductions and so forth. But we already have the slide in front of us. This is a great picture of the wind resources. So this is from the National Renewable Lab, and basically this says, quite frankly, where is the wind? Where does the wind blow a lot? And you can see in the mid part of the country, the Dakotas and even North Texas, where in fact, Texas is the largest wind generator in the country. You can see there's a tremendous resource there. Well, now you got to build transmission lines to get it where the load centers are. And we have a lot of that underway. And I think the new administration will push even more of that. You can see in Ohio, it's kind of mixed. It's a little bit better in the Toledo part of the area. We have wind farms in Ohio, a number of them. That Appalachian Ridge, First Energy has a number of wind farms over there. The other thing on this chart that's really interesting is the offshore capability. And we all know that if you spend some time on the Atlantic side of the wind is always blowing over there. It's always a great footprint. So there's a lot of politics behind offshore wind. We really don't have any here in the U.S., but the rest of the world's got a lot of it, particularly in the North Sea. And there's just a tremendous amount of wind generation over in Europe. So I think we're trying to follow that lead. If you look at the next chart, the actual wind generation here in the United States, this is kind of state by state, and you can see where it is. It kind of follows the footprint. So the more of this we develop in parts where the wind resources aren't very strong, it's going to be not as efficient. It's going to be a lot more expensive. So we'll see how that plays out. Everybody wants wind and solar, but there's places in the country where it just doesn't work very well. So that availability is going to be a lot lower. Looking at solar on the next slide, same kind of idea here. This is where the sun shines, and as you can see, that Ohio is not doing faring pretty well there. We do have solar facilities here in Ohio because we are able to get energy from the sun, but the southwest part of the United States is a much better resource for solar, and there's a lot of it out there. Arizona Public Service has huge amounts of solar programs for their customers. Rooftop solar is very, very common in Arizona and California. So similarly, on the next slide, you can see where the utility, the next slide is a utility scale. Now what that means, Mike, is the large solar arrays. So this really doesn't count all the rooftop stuff, which is very difficult to kind of keep track of, frankly, by the utilities, because somebody just puts it up, and it's there. But you can see California, Arizona, some in Texas. This is where the strength is in terms of solar generation by state as of the end of last year.
Very good. And leaving that up for a second, I was just thinking about, again, we could talk about lots of different things, but when people think about solar, they think of solar PV, photovoltaics, and especially since UToledo is a world-class research institution in that area, and I'll ask you about that in a minute. But I get excited when I see the solar thermal, the boilers, solar boilers out in the West, and the idea. You may recall my research is on designing for safety and how sometimes the idea of how we're going to construct this thing needs to drive the whole decision. And when they do those things like Ivanpah and Ivanpah, right, 340 feet in the air or meters in the air, and how the heck are you going to do that? And it's amazing, those systems. Do you see solar thermal or solar boilers increasing, or is that just a little niche area, one small part of the nation?
Well, I think it's more than a niche. The real challenge you get into, Mike, is the economics. And with natural gas heating, and this is the real push and pull here, with natural gas heating being so economical here in the U.S. In fact, we're exporting natural gas through LNG terminals now because we've got so much of it. The push and pull is going to be because natural gas is a fossil fuel. How's that going to play against all of these options, wind and solar, and even the boiler option? Again, it's a lot less applicable in areas like Ohio, when the sun comes out in Ohio, everybody looks up in the sky and says, what's that big orange thing, So we have a lot to do there, but the economics is probably going to drive a lot of this.
Yeah, absolutely. Well, great. I got one more question kind of that we had talked about, and then we'll go to, we're getting some excellent questions from the participants. So again, I encourage everybody just enter it in the chat, just like you've done, and I'll get to those in a second. But Gary, you've done some neat things here as a scholar. Not only you're teaching, and I want to hear, but also scholarship. Let's start with the teaching. In particular, I am so thankful as the dean for what you've done with my predecessor, Nagi Naganathan, to create the Leidich Energy Engineering Program. And we have a master in energy engineering management. How did that come along? And tell me what that program is about.
Well, thanks, Mike. I appreciate the kind words. And it started many, many years ago. We were talking about with some of the utilities involved. Should we get back into power systems? Because when I attended here back in the day, the power systems program, as it was in many universities, was very strong. And we've got a few good courses now, but we really don't have a curriculum. Well, as we talked through that, we thought, wait a minute, there's a lot more to this than kind of just a narrow power systems view. Let's broaden the whole topic into energy and get into the entire subject. So the curriculum includes business courses, a little bit on finance, a whole variety of approaches here. It's almost like a master's of business / engineering, but focused on energy. And I've been thrilled to be able to support it and to be able to teach the course. And I think the students are walking away with a lot more than just the technical stuff. There's a business side of it and all that. In fact, I was delighted to hear from one of my students the other day. She had just landed a job at AEP as a junior electrical engineer. So it was thrilling to see her get into the business. That's one. So we're working through that, and it's a good program. It's pretty popular, and I'm really enjoying being able to contribute.
Yeah, and then we appreciate that. And I gotta say, he's so proud of that program director is Dr. Raghav Khanna, who is one of my favorite faculty because he just gives and gives and gives. And Gary, I hope you know, he just got tenure. So congrats.
Oh, wow, that's great.
Yeah, he just got tenure. So we can't get rid of him if we try. No, that's not true. Anyway, so
don't you dare.
That's a neat program. I want to turn before we do. Actually, let's do about your research, which I know sometimes is with Raghav, Dr. Khanna. Talk about that, and then Ted Kester has a good question for us about Ohio. But first, tell us about the research projects that you're involved with here at UToledo, because I think they're important.
Yeah, a couple of things. First of all is with Dr. Khan, and we're working on a proposal that's has been submitted to the national labs as part of DOE. And it's about smart grid in the broadest sense, but it's in a little more narrow. It's about integrating customer-owned generation and how you can optimize that reliability-wise as well as economics of it. So we're excited. Hopefully, we'll get that research project. It's an expansion of a project that's already been done here at UToledo with the Scott Park campus. So a lot of good work going on there. And the other one I want to mention is hydrogen. And Mike, you recall we had a workshop a couple years ago, year and a half or something, here at UToledo about hydrogen. Very well attended. I think it was standing room only, if I recall, and lots of presentations from the national labs as we head towards, what's known as a hydrogen economy and relying on hydrogen as a fuel source for a number of different things. And the Davis-Besse nuclear plant, formerly with First Energy and part of my portfolio over the years, is doing a demonstration project along with other utilities to take the hydrogen that's produced from the light water reactor and actually make it commercially viable in the market. So rather than going through the whole process with electrolysis of water and all that, we can get it right from a nuclear reactor. So exciting project, and it has a lot of interest from a lot of different sources.
Yeah, and it's neat. You may recall, of course you did, because you participated in October 2019, I believe it was, before the pandemic. We had this awesome workshop here focusing on this very thing, partnering with Idaho National Lab and others that came in. We were so honored to have them, right, all these leading scientists on our campus. In fact, they were in my conference room working out some things afterwards, and what a neat conference that was. But just the idea of, when we think about, yes, we need to move and to a clean energy and more affordable, more reliable, well, that doesn't mean we tear down everything. Now, coal plants, as we know, we put in scrubbers, really hard to get that where it needs to be. But in this case, to give a second life to these light water reactors and nuclear reactors by taking the hydrogen and absolutely using it to do that green up our economy and use it for, I think it could be used for not only energy source, feedstocks for various not petrochemicals, but other farm and things like that. So it was very exciting. I hope that moves forward. So thank you for doing that and working on that project. Fingers crossed that we keep that moving forward.
It's a good one, yeah. And I would offer a little commercial here for nuclear. The other thing that's going on in the industry, which is very important, is advanced nuclear reactors, including small modular reactors. And there's a tremendous effort with the Department of Energy and a number of companies, including Westinghouse, GE, and some of the big partners, to develop smaller reactors, smaller scale. They're safer, manufactured in a facility, and so there's a lot of opportunity there. And I think nuclear, knock on wood, a little bit of a renaissance here. I think as a result of our carbon goals, and that it should, because it's a carbon-free source and there's a lot of public, opposition to it, but you got to remember you can't generate and consume electricity without impacting something.
Right.
That's what people have to try to remember.
The
other thing I wanted to mention, hey, Mike, one quick anecdote. I was going to include this in my opening comments, but today's Earth Day, right? And April 22nd, 1970, I was on campus for the very first Earth Day. And that came out as a result of a lot of unrest in the campus that was going on for just about every issue you can imagine. So we tacked on environment to the, we sort of had skills at unrest back then, and we tacked it on and had Earth Day. And I remember that very well, and it's really good to see that we're celebrating it, 50 years later. That's great.
Yeah, very good. And it was funny, you remind me it's Earth Day. My first Earth Day, I think I was 10 years old, and I walked around Mendon Ponds in upstate New York celebrating it. Didn't even know what the heck I was doing, but I'm really glad that we're still celebrating it. So thank you. Hey, so somebody that I've missed, Bill Kester, a longtime supporter of the university and the College of Engineering. Bill had a good question, and Bill, hopefully get together you and Carol before too long. I know once this pandemic. Anyway, Gary, can you discuss the big outage that occurred in Ohio and the East when the transmission lines went out of service? We in Defiance were saved with the natural gas peakers here, but how did those big transmission lines slip?
Well, yeah, I was with the company then, so I could do an hour on this one too. But the short version is that there were some generation outages, and there were also some tree trimming issues, and a number of things that caused voltage instability. Basically, is what happened. and it went on for quite some time. So it wasn't necessarily well monitored across the grid. And when we finally had it, and the load, it was a very hot summer day in August, and the load was very, very high. So the lines sagged into trees and caused a cascading outage. Very famous outage, obviously, very challenging for First Energy and all the utilities. And we got the system put back together. The offshoot of that is that the standards that were voluntary for transmission operation and design became mandatory. And over the years, the North American Electric Reliability Council, NERC, which essentially has a delegation agreement from the federal government, enforces those standards. And the organization I'm involved in out west does exactly that. They enforce reliability standards. So we used to operate with a lot of sort of voluntary standards that, you know, didn't have a lot of tight enforcement. That has changed dramatically since 2003. Hopefully
Very
that
good.
helps.
Yeah, no, that's good. So here's another question, a good one from somebody else I missed, Don Warner and Connie, although I did get a set eyes on him a little bit a couple of times during the pandemic. Energy storage is going to be a key issue going forward to make renewable energy available when demand needs it. What's the current status of battery and other types of energy storage? And while you're thinking about it, I want to just do a plug and remind folks the very first town hall that we had, I can't remember, Jen, when was that? Maybe April or something, that Dr. Sandrine Mubenga from our electrical engineering technology and her former doctoral supervisor, Dr. Tom Stewart, who was on, I think, listening to this too, has done some great work on bileveling within batteries. So it's not quite the commercial standpoint yet, but here at UToledo, we're doing an important part of it. So answer that question, Gary, about the future. And you know what, maybe this is the first time we've talked 45 minutes and Elon Musk's name has not come up. So maybe this is the time to talk about that.
That's another hour-long discussion, Mike. The short version is that I'm a big fan of storage, and I think, you know, most people realize it that are listening in, but you know, you can't store this product. You can't store electrons. You can convert it. You can store it chemically with a battery. Most of the storage here in the United States, about 90% of the generation that's actually storage is hydro. It's pumped hydro. And the simple version of that, as you know, is you pump the water up to a reservoir during the nighttime when electricity is cheaper, and then during the day you release it when you need it at peak load. So we have a lot of that here in the United States, and that's being built all over the world. It's tough to build. It requires dams, it takes land, environmentalists, so there's a whole raft of issues with that, but that's the biggest contributor right now. Battery technology is moving along very quickly. It's highly competitive. There's a lot of different technologies, and of course I talk about flow batteries and all kinds of different configurations. The lithium-ion battery is obviously the most popular. It's got its challenges, as we saw recently with the Tesla crash, unfortunately. So there's a lot of work to do there. The government in the administration's plan has a lot of funding for battery storage, and we have a lot of proposals all over the country for battery storage facilities. But just to give you the numbers right now, we got about 4,000 megawatts of battery storage here in the United States on a footprint of about 110,000 megawatts of generation. So we got a lot of work to do there, but I'm optimistic that we'll figure that out, and hopefully other storage technologies as well.
Good. And why did I mention Elon Musk?
Well, actually, you know, he's got a huge battery R&D facility outside Las Vegas. So he's cooking up something behind those closed doors, and hopefully it'll be something we can use in the utility sector.
Yeah. Isn't it called the Powerwall or something like that? I should know. It's the idea of a consumer unit that you would use that you charge up from renewable, I think, and then it would drive lots of things, including charging your EV car. Anyway, yeah. So Mike Green is both an alum and a UToledo employee, and he and I compete for I have an EV car. And so I went to charge this morning, Mike, and somebody's Beamer is on there again. We need to talk about that. So I got to go take it tonight and charge it. But anyway, Mike's question, he's trying to get us a little controversial here. He said, so how about, he wants to go back to Texas because it is an interesting thing. How does the Texas population boom affect the outage? Is the infrastructure keeping up with the expansion rate? Does anyone track that? And then the question, the balance between, fossil fuels, solar, and wind. So while you're thinking about that, let me just mention that as a civil engineer, I did judge Texas a little bit because I spent some time, used to work for Brown and Root. I was down in Houston, and that's where we had very poor stormwater policies. And again, it's in the name of, you might say liberty or freedom or letting the economy roll with development. But in the end, folks, when you don't take care of your infrastructure and you make it, all of a sudden they were designed for, 10-year floods and all things would. So that's my sense as a civil engineer. But without getting too controversial, how about this balance of renewable energy versus fossil fuels, and how much did it affect it in Texas?
Yeah, it is. It's easy to get, to offer up a whole bunch of crazy opinions about this thing, and they've got to sort through it and deal with it. And they're doing it probably in a more insulated fashion than other parts of the country would. So I'll offer that. The balance between solar and natural gas, Texas is about 51% natural gas, and they've got about 30% wind. The wind footprint is very good, as we saw earlier in Texas. So they really harvest the wind, and then they have a bunch of transmission that gets it over to Dallas and Houston and those areas. So their balance is not bad. They've got 2 nuclear plants, 4 units total. So I don't think that's the issue as much as just kind of how they approach reliability. They have enough conservatism in the design. They've been very focused on rates. Their rates are not the lowest in the country by far, but they're competitive. They're in a little bit better than we are. But they've been very focused on the cost, and maybe reliability has suffered a little bit as a result of that. I think they're going to have to take another look at that. That's my opinion, and be a little bit more mindful that reliability is important. And again, you can rationalize the whole thing with whether it was too cold, but it's a lot more complicated than that. And they're really going to have to look at their policies and how they kind of do business down there.
Very good. So another person who knows a heck of a lot about electricity and energy is Dan Farr, well,
Yeah.
former executive with DTE, and again, very proud to have him as an alum. He sent me a number of very technical questions, and we won't go into some of them, but one he just pointed out that was interesting. He said, energy storage is about cycle efficiency. And he mentioned the Ludington in Michigan is one of the largest pump storage facility. I'm not familiar with that. Tell us, since that's kind of in our backyard, I guess.
Well, yeah, it's in northern Michigan, and it is one of the largest pump storage facilities. The largest in the country is actually in Bath in Virginia, partially owned by First Energy. And these facilities were built many years ago when it was kind of easier to build those kind of things. And it's really great because we've got a fair amount of nuclear here, and nuclear runs 24/7. So you basically pump up the reservoir at night using nuclear power and putting it to good use. And then during the day, you don't have to run natural gas as much and peaking units as much because you've got that energy available from pump storage. It's in the northern part of the state, so it doesn't get down here as much. It's part of the Michigan interconnection system, but it's a great resource. And if you could wave a magic wand and build more of those, that would be great. But again, you're impacting the environment when you do that. And I tell you, they built one over in China and displaced 1 million people doing it. So it's tough stuff sometimes.
Yeah.
So, interesting. Yeah, Dan, I can see in the chat room there's a whole bunch of stuff here. He's just trying to trip me up a little bit.
So we only have about maybe 2 or 3 more minutes, Gary, and this has been wonderful. One of the questions that was sent in by one of the participants or pre-registrars ahead of time was, what's the future like for municipal electric utilities over the 10 years? And help us to understand what that term means, the municipal electrical utility, and their special challenges.
Yeah, the utility, if you took out a clean sheet of paper and designed the utility business structure, you would not do what we're doing here in the United States. Okay. We've got thousands of utilities. About 75% of the market share is investor-owned utilities, companies like First Energy, DTE, AEP, those kind of companies. But over the years, municipals have decided to form their own utility system. They have a lot of water systems, but some of them also have their own electric systems. And there's co-ops. That's a whole other model. So that we have all these different potpourri of different business structures. I think the challenge going forward for municipals is the security of the power supply itself. When municipals started back in the day, a lot of them had these little coal-fired power plants, and they ran their own plants. In fact, many of them ran their own little systems, not even being connected to anybody else. Well, they've all interconnected now, and that improves reliability. And many of those plants have been shut down because of environmental and cost constraints. So most of the municipals live off the power market, if you will, and depending on where you're at in the country, that could turn into a challenge, an expense, as well as, the necessity to buy green power, if you will. There isn't really no such thing. It's there's green electrons per se, but to make sure that they're sourced from environmentally friendly facilities. So I think the sourcing is going to be the real challenge. The transmission distribution work is pretty routine, pretty bread and butter. Systems are getting old. Poles are old. Systems coming apart in some ways, but people are getting after that. So that's what I'd offer.
Very good. I think this is a kind of a quick one, but it's a good question from our friend Dr. Carol Kolleritz, health, physician, retired from the University of Toledo. And good question. What's the potential geothermal energy? We haven't talked about that today. It wasn't on your, but that's a good thing because it's on the radar of some. Especially, I may have told you, Gary, a trip to Iceland, looking at renewable energy there and the geothermal. But that's not the U.S. So anyway, tell us about potential in geothermal in the U.S.
Well, it's very, very much a function of the resources and the geography. And, just like wind and solar, I mean, to make solar economic here in Ohio is a real push.
Yeah.
Given the resources. And geothermal has the same attribute. There's a lot of it out west where it's conducive. There's a lot of it individually with customers, residential facilities. It's very capital intensive. It's expensive. So that's the big challenge is, just the cost of doing business there. I think it's there, Mike, but I think it's going to continue to be a pretty small player in the grand scheme of things. There really isn't much what I would call utility scale geothermal, hundreds of megawatts. So we'll see.
Yeah, let me just mention that, don't forget, it's always neat when we talk about energy to look at the localized. And Jen's come on, so Jen, just give me one more second here. Sometimes we need to think, you said, not utility scale, but at the local level. And in particular, anytime we go into the ground or sometimes 50 feet down or 100 feet in the water, ocean water, there can be thermal gradients that we can tap into. So, of course, we on our individual houses, as you said, it's still capital intensive, but you can put in, go down 100 feet and do a geothermal loop and constantly grabbing that 50-degree water and, using that. And so we can do that. It's expensive, but it really can help with a, per seasonal cost, it pays out.
Right. And environmentally, it's pretty good once you get it all set up. So there you go.
Right. Yeah, very good. So Jen's going to yell at me because I've talked too much during this time, but I get excited about energy, and it's so important for all of us. It really is. And here we got one of the world's experts and a local expert with us today. So how fortunate we are. Gary, thank you so much. It's been an enjoyable hour. I'm pretty sure everybody else will agree with that as well. So thank you again. And for all you do for the university, very much appreciate that too.
Thank you very much, Mike. And it's been a good time, and I'm delighted to be able to give back to UToledo. So thanks much.
Very good. Yeah. Jen, I'll turn it back to you.
Yeah, thank you, Mike. Nobody wants to hear me, no problem. Gary, a real sincere thank you. You are one of our college's most passionate supporters and one of the great leaders within the energy industry. And we are so grateful for your time and your talent. And of course, Mike, you make moderating look easy. So thank you as always. And a big thank you to each and every one of you in our virtual audience for making time to join us for this town hall and hopefully some future town halls. I really enjoy seeing each and every one of your names as participants, and we appreciate your ongoing interest and your support. And as always, I hope you'll continue to join us for future events. And if you have specific ideas on what you would like to see, or if you'd simply like to connect with the college, feel free to reach out to me directly. My contact information is on the foundation website, and it will also be in the email that you will receive following this town hall. Thanks so much, everyone.